We are going to begin our new unit by looking at key features of graphs. We're going to split this into two separate lessons. So today we're only going to focus on part of the key features, and then in our next video we'll focus on some different ones. Okay, first thing I want to look at is function values. You guys will remember this from the last unit. And if I have something like this function notation means go to function f and find its value when x equals -5. Well, in this case, I don't have an equation of function f, I just have a graph. But that's okay, I can still do it from the graph. So I will go to the x value of -5, and then the answer, what goes in the blank, is the y value. So if you look at this point right here, the x value is -5, the y value is 0. So the function value at -5 is going to be 0. All right, how about -3? So I'm going to go to -3, go until I touch the function. Now, what y value is that? That is a y value of 5. So the function value of -3 is 5. All right, the x value of 0, that's right here. And the y value of the graph, I'll go down till I touch the graph. The y value there is -5. And then at 4, right, there's my x value of 4. My y value is back to 0. So we have some special names for some of these. When the x value is 0, like in this one, we call that the Y-intercept. And when the y value is 0, like we have in this one and this one, we call that an X-intercept. Now, a function can have lots of X-intercepts. It might only have one, it might have none, it might have lots, but it can only ever have one Y-intercept. Otherwise, it would fail the vertical line test and it would not be a function anymore. Okay, so based on what we just looked at, what are the X-intercepts? When we type these into Delta Math, it is not going to expect us to type a point. It's just going to expect us to type a number. So the X-intercepts, instead of typing this as the point -5, 0, it's just going to expect us to type -5. So I have the X-intercepts are at -5, -2, and 4, right? Because you remember that's where it's crossing the x-axis. We just looked at those. And the y-intercept, that's where it crosses the y-axis, and that's there at -5. Okay, let's look at using the calculator to find the x-intercepts and the y-intercepts. So I have the calculator here, and I actually already have that function for us in the calculator, but I can't see anything. Sometimes you guys get confused when you try to graph and you can't see what you want to see. So a good way to find stuff is to go to Zoom and go down to number 6, Zoom Standard. Now I've put it back in the standard viewing window of -10 to 10, and now I can see the graph. Well, I can see that this one has 2 x-intercepts here and here, and it has 1 y-intercept right here. So write down the keystrokes that you need to find the x-intercepts. All right, so this calc right here, that's what we're going to do. So second calc, and then I am going to be finding an x-intercept, which our calculator calls a 0. A 0, an x-intercept, a solution, all of those are the same thing. So I'm going to hit number 2 for 0. Okay, it's going to ask me the left boundary. Well, if I'm searching for this point, if I move to the left, you can see I'm going to be up here. So I'm going to use my left cursor and go past that point to the left. It doesn't matter how far left, I just have to be left. Now it's going to ask me for the right bound. So I'm going to use my cursor to go over to the right. Again, it doesn't matter how far, just as long as I go past it. And then it asks me to guess. So I'll get as close to it as I can and hit enter. All right, and there is the x-intercept right there. Okay, so let's round that to the 100th. It's going to ask us to round that to the 100th place. And the value was -3.23. So my x-intercept is at -3.23. Okay, let's pull the calculator back up here again because I noticed that there are 2 x-intercepts. Now I have to find this one. Okay, so let's remember, make sure you write these down. First you hit second and then trace to get to the calculate screen. And then the thing I want to find is a 0. An X-intercept is also called the 0 of the function. All right, it's going to ask me those same questions, left bound. Well, this time I want to find this one. And if I'm moving to the left, you can see I'm below it. So I'm going to scoot over there until I'm below it. Right, there I am on the left. And then I'll hit enter. Okay, now it asks me to be on the right-hand side. So I'm going to go past it to the right. So I'm going to use my cursor here to go past it to the right. And it doesn't matter how far, as long as I go past it to the right. All right, and then it's going to ask me to guess. So I'm going to go back to the left, get close to it there, and hit enter. And there's my second 0, my second X-intercept, 1.24, right? You guys remember the 6 rounds the 3 up to a 4, so 1.24. Okay, so now I have found the X-intercepts. Let's find the Y-intercept. All right, so again, I'm going to go to that calculate screen. So write this down, second, calculate. All right, and what I'm going to be finding this time is a value. So I'll hit enter on value. Now it's going to ask me what X value I want to use. Well, when I'm finding the Y-intercept on the Y-axis right here, all of the X values are 0. So I'm going to hit 0 and then enter. And it tells me that my Y-intercept is at -4. All right, so there's what I have for that first one. X-intercept of -3.23 and 1.24, rounding to the hundredths place, which is 2 numbers after the decimal, and then the Y-intercept of -4. Okay, let's do this one. I'm going to put this one again in my calculator. Okay, you guys can see I've got that on the Y equals screen right there, and I'm going to hit graph. All right, so this time, again, I have 2 X-intercepts. All right, see if you can remember what to push. Read what you wrote down before. First, I'll hit second, and then trace to get to the calculate screen. Now, which one of these do I want to choose if I'm looking for the X-intercept? I want to choose 0, which is number 2. All right, so it asks me to be on the left-hand side of this point, so I'm going to have to move down here, past it to the left. All right, there we go. Now it's going to ask me to be on the right-hand side. So I'm going to move past it to the right. And then it's going to ask me to guess. So I'll scoot over close to it and hit enter. And I get -1.5. Okay, so my first value is -1.5. I don't have to round that one. It doesn't have a lot of numbers after the decimal place. So I'll just put X equals -1.5. Okay, now let's do that again to find the second one. So second, trace to get to the calculate screen. Again, I'm going to choose number 2, which is 0. Okay, it's going to ask me to be on the left of this point, so I need to scoot my cursor over here. I'm going to stay above. I'm going to stay to the left of it, but I do need to scoot over there closer to it. So let's go a little closer. There we go. So do you see I'm on the left-hand side of that point? Hit enter. Now it says to go on the right, so I'm going to go past it to the right and hit enter, and now I'm going to guess. And this time it's 1. Again, I have nothing to round because it's a whole number. X equals 1. Okay, let's find the Y-intercept. So this time I'm going to do second, calculate, and I'm going to do a value, which is number 1. All right, and let's see, the value that I want to give it to find the Y-intercept here on the Y-axis is 0. So I found that my Y-intercept is at 3. Okay, so look right here. I can find any function value doing that. You guys remember the ones we did on the last quiz? I can do that this way also. So I'll pull that up, second, calculate. Let's find a value. This time, instead of finding the y-intercept, I'm just going to find what is the y value when x equals 0.75. And there it is right there, 1.125. So it'll tell you any value that you want. You can just hit that value and you can find it. Okay, let's get some definitions. Maximum. A maximum is a point which is higher than all the other points over a specified domain. It does not necessarily mean it's the highest point in the whole graph. It just means it's the highest point in its area. So look at graph A here. In graph A, I'm going to have two maximum values. I have one here and I have one here. A maximum is just the highest point around. It's the top of the hill. So we often call that a local maximum because it's not the maximum of the whole graph. You can see right here that the graph is going up to positive infinity. So that can't be the maximum value, but it's the maximum in its area. It's the highest point around because it's the top of the hill. So when you put these into delta math only wants the y value, because we say that the local maximum occurs at the x value and the maximum value is the y value. So I have two maximums in this graph. One of them is at 2 and one of them is 1. So the maximum value of 2 occurs when x equals -3, and the maximum value of 1 occurs when x equals 2. Okay, let's look at this graph down here. Again, you can see that I have 1, 2 maximums, and this one is the maximum of the whole graph. It does not go up to infinity. Okay, look, my little numbers are going up by 2's right here. So the maximum value of this graph occurs right here. That's 8. And I have another local maximum down here. That's the highest in its area, and the maximum value there is 2 because it's one little tick mark up. Okay, how about the minimum? That's exactly the opposite. The minimum is the point that is the lowest in its area. So again, it's not necessarily the lowest of the whole graph, it's just the lowest in its area. So if you look at graph A, you'll see that I have a minimum here and I have a minimum here. Neither one of them is the minimum of the whole graph because the graph is going down toward negative infinity. You can see the arrow there. They're just the lowest point in their area. It's the bottom of the valley. So I have two minimum values. One of them is -3 and one of them is -1. The minimum value of -3 occurs at the x value of -1, and the minimum value of -1 occurs at the x value of 4, but the minimum value is -3 and -1. Okay, looking at this one, I only have one minimum on this one. These go on and on forever down. They're going toward negative infinity. So it's not the lowest point on the whole graph. It's just the lowest in its area. And that y value is 0 because it's on the origin. All right, we can use the calculator to find maximums and minimums just like we could for x-intercepts and y-intercepts. So let's pull the calculator back up again so that we can do that. Okay, I have the first one graphed for us. You can see that this one has a local minimum, but no local maximum. It goes on and on forever up, but it does have a local minimum right here. So to find that, write this down, second trace to get to the calculate screen, and we're going to go down to number 3, which is minimum. It's basically going to ask us the same questions as it did with the x-intercepts. I'm going to go to the left of the minimum and hit enter. And then I'm going to go to the right of the minimum and hit enter. And now I'll go back to the middle and guess and hit enter again. All right, and there's my minimum value. So if I round that, here's my minimum value. If I round that to the nearest hundredth is what Delta Math is going to ask me to do. In this case, it's an integer, so I don't need to round. The minimum value is at -5, and there is no maximum. Okay, I have this next one graphed for us, and you can see that this one has a maximum value, but no minimum. It's the same buttons, second, calculate, you're just going to go down to number 4